and we can go through it. Okay, welcome everyone to session 9 of ISTQB training of CTFL, and I hope you all are doing well. So just to recap, last session we finished the test levels by completing acceptance testing. In the questions which I sent for the last session, there was one question where there was a little bit of confusion, and Jatin asked me if we can go through the answer in the session. So I thought like I will include that first, and then we can proceed with our next topic. Okay, so this is one of the question. Which of the following is not a characteristic of alpha testing? So C is the correct answer for this one. Alpha testing is also called factory acceptance testing. Okay, alpha testing is not called factory acceptance testing, so this is the correct answer. But option B, few of you were confused with option B, that what does that mean? So let's go through that, and I will try to explain that as well. Option B says system is installed at user organization and user test the system. So we know that in alpha testing, the first one definitely is correct, that it's created at developer site and user test the system, which is perfectly fine. So second one, then kind of it contradicts, and that's why it was a bit confusing. But I'll give you a situation, and within that, then you will understand that how option B is a correct option as well. So I will take this example, which we did in last session as well. So over here, we took a scenario where a third party, company XYZ, developed a software for a client and did component integration and system testing at their own, in their own organization, and then handed it over to the client for acceptance testing. Okay, so now we shouldn't forget that alpha testing, beta testing, OAT, UAT, all of these are types of acceptance testing. So in this scenario, we said that, yes, okay, when it comes to client will do UAT, and if there are any issues, then they will be fed back to the company who developed it. So when we are saying UAT, so UAT is mostly done, in this case, maybe the test team and maybe the product owner, etc. So one scenario is that over here, yes, UAT is passed and client is happy and is happy to release it to production. But there can be another scenario as well, where after UAT, maybe the client still wants to do alpha testing as well, or maybe beta testing as well. So after UAT is done, then the client wants to do alpha testing, which means that in their own organization at client side, over here now client is our user. The client is a user. So user will get it installed in their own organization, as the term says over here. System is installed at user organization and user test the system. So over here, this is user. At user organization, the software will be installed, and alpha testing can be done by not the immediate testing team who's working on this project or the developers, but any other pool of users from the client's organization. So the terminology used over here is a bit confusing, but I hope that this example clarifies it. So Jatin, can you tell me if it's clear or is it still confusing? Oh, Jatin is saying now it's clear. That's good, right? Okay, so we can then start with our today's session. So today we will go through test types. So we have covered test levels, and now we will cover test types. So let's see what is a test type. A test type is a group of test activities based on specific test objectives aimed at specific characteristics of a component or system. And then in this syllabus, we will go through these 4 test types: functional testing, non-functional testing, white box testing, change-related testing. Okay, so now one very common thing or mistake which usually people do is to mix test types with test levels. So I know when it comes to terminologies in testing, it is sorry, it is sometimes a pain point that the terminologies can be mixed together, and somehow the same terminologies are used separately by different people, and sometimes it's not wrong even. So let's first clarify that what is test level and what is test type. So a test level is basically a level of software testing which is basically a process where different test types can be performed. So we saw that we have 4 test levels: component, then integration, system, and acceptance. And all those levels are process itself in a software. And within those levels, then different types of testing can be performed. So which can be one of these. So there are many other types of testing. Maybe further, these test types can be divided into further many other types of testing. But for now, we will cover these 4 broader testing types. Okay, so first one is functional testing. So functional testing, by now, like in the test levels as well, we have gone through this term functional and non-functional testing a lot of times. So I hope that the scope is clear that what are we trying to test in functional testing. So whenever we are performing functional test, the focus is that what a system should do. So most of the times we have our requirements in any one form. There are different forms which we already discussed in the test levels. So based on any one test basis, we come up with our functional test cases, and then we check. And the focus over here is what a system should do. And the next one is when it is performed. It can be performed at all test levels. So we will go through those as well in the next slide. But functional testing can be performed at all test levels, but the focus on each test level will be different. Then there is another terminology, black box. So black box and white box, both of them, they are used side by side most of the time. So black box techniques we will study in the later module. For now, just to explain you that if we are testing any software where a user gives some inputs and then we see an output as a response, that's black box, because we just see a user interface and some result. We don't know in between what's going on. And so in between, if we see that, okay, what are the procedures which are going through, then that's white box testing, which we will cover in a while. But just an overview that what is black box and white box, we will cover in much detail in later modules. So let's not confuse yourself with this. So black box techniques may be used to derive test conditions and test cases. Then when it comes to functional coverage, so black box techniques basically is checking the behavior of the system, how the system behaves. But then another question is that how we check the thoroughness of functional testing, that how thorough our functional testing is. So for that, to measure that thoroughness, we use this terminology known as functional coverage. And what is functional coverage? We have covered that before as well, but not this in this term. So we have covered the traceability before. So how we can check the thoroughness of functional testing? That when we check the traceability between tests and the requirements, we can map each test case to each requirement, and then we can identify if there are any gaps. And if there are not any gaps, of course, we can, in either way, we can say that whether we have 100% functional coverage or maybe 90% or 80%. So we get the functional coverage in terms of percentage. The next point is special knowledge might be required for functional test design and execution. For example, business domain. Okay, so when we are doing functional testing, though we know how to write test cases, how to derive all the test conditions from the given test basis, but still it always helps if in the system you are working on, if you have special knowledge, if you are more knowledgeable or you have skills in that domain. For example, if I am now working in finance industry, so it's more likely that I understand the systems in finance domain more than maybe in e-commerce, because maybe I haven't worked on e-commerce domain at all. So it will take me a while to understand how the systems work in an e-commerce domain. So each business domain comes with their own skill set, and many times even the experienced testers as well, they can be experienced in testing, but if they are switching to a new business domain, it does require some learning curve to understand the systems. Okay, so the next one, as we said, that functional testing is a testing type which can be performed at all test levels. It doesn't have to be performed at all test levels, but it can be performed. So now what we will do, we will take an example of a credit card application where there is a website where we can go and we can apply for a credit card. So we'll take that application as an example, and then we will go through all the test levels, and then we will see that at each test level, how functional testing can be performed. Okay, so first of all, it will be component testing. So at component testing, we can check, so it's just like one of the example, there can be many other scenarios. So one of the example can be that how interest rate is calculated. So if we are applying to a credit card and maybe based on our credit score, we are given different interest rates options, and how those interest rates are calculated, there will be a separate component for that. So in component testing, this is one of the example. Then second is component integration testing. So integration testing, I have split it in component and system integration testing. So in component integration testing, now over here, if we recall that what is component integration, that yes, there are two or more components and we are checking the communication, the integration between those components. So over here, we can take this example that user interface info passed to business logic, for example, age of applicant. So there will be a criteria of minimum age of the applicant. Let's say that it's 18, that anyone who is whose age is less than 18 can't apply for credit card. So of course, when we are filling the application form and date of birth is calculated based on the age given, then that info is passed to a business logic, and then based on that we will show the next screen to the applicant. If it's less than 18, maybe we will not even let the applicant proceed to the next screen, and we'll just give a message that unfortunately you are not eligible to apply for the for credit card. Or if that applicant is 18 or more, then of course they can continue with the application. So over here, what we are doing, that there more than one components are communicating to each other. They are passing information to each other. So this is one of the example for functional testing. Third level is system testing. System testing, it would be very simple that what we are doing, that we are filling the application form and we are applying for credit card. So this will come in system testing. The next is system integration testing. Right, over here in this example, when we are applying for a credit card, if you have applied ever for a credit card, you would have seen that most of the time at runtime, the credit score is evaluated. You get your credit score at runtime. But what happens that there is an external API, maybe another third party, who actually um, calculates your score and provides you the response based on the information given. And mostly the information which a credit card company who evaluates our score, they need few parameters like name, date of birth, and address. So an applicant entered all these details, and then an API was used to calculate the credit score. So over here, there are two systems, system integration testing, that our system, which was a credit card application, is integrating with another system which is actually calculating the credit score and sending us the response back. So this will be an example of functional testing in system integration testing. Then the last one is acceptance testing. So in acceptance testing, an applicant can successfully apply for a credit card, which means that an applicant is able to go through the entire application process successfully. And at the end, based on all the details given in the application form, either the application is approved or rejected. So this will come under the functional testing of acceptance testing level. Any question on this page? Otherwise, we will move to the next testing type. Okay, let's move to the next one. The next one is non-functional testing. So over here in non-functional testing, the focus would be that how well the system behaves. In functional testing, the focus was on what the system does. But over here, the focus is how well the system behaves. Now, non-functional testing can also be performed at all test levels. Though it's not performed at all test levels, but there is no reason that why it can't be. So it is applicable. Again, black box techniques may be used to derive test conditions and test cases. So there would be different separate test cases for non-functional testing because the objective of this testing would be entirely different from functional testing. Now, just like we did functional coverage to measure the thoroughness of functional testing, we have non-functional coverage to measure thoroughness of non-functional testing. In functional testing, the example of measuring the thoroughness was the traceability matrix. Over here, we are taking the example of testing compatibility of browsers or devices. So the same application form, if it can, we will check under non-functional testing if it is compatible with on different browsers and devices. So it will be compatibility testing, which will be further a branch of non-functional testing. So we are not checking any functionality over here. We are just checking that everything looks fine, the application form looks fine in different browsers. Just like functional testing, special knowledge might be required for non-functional test design and execution. For example, security vulnerabilities associated to a specific programming language. So whenever we are using a specific programming language, they have their own limitations. And based on the limitations, there might be one programming language, specific one, have some security vulnerabilities, which means that if someone has worked on both, let's say Java and C#, then and they know it quite well, then it will be easier for them to identify any kind of security loophole based on their previous experience. So yes, for non-functional testing as well, there are some special knowledge which might be required. Now we will take non-functional testing type through all the test levels. So starting from component testing. So now we are still doing credit card application, but now the way we are seeing this type of testing is different. So in component testing, in non-functional testing, we'll be seeing, let's say, performance. We'll perform test to evaluate the CPU usage for various components. So we have multiple components, and each component might be using the CPU in different way. And sometimes, like when you are let's say you're filling an application form or you're in a website, and at certain point you will see that the system, the website, it slows down. Why it slows down? Maybe at the back end, it's the specific component is processing something, and which is using the CPU to its maximum level, and that's why it's taking longer to load or taking longer to process something. So that's why performance test can be performed for each component to see if there is a spike for any specific component, and if yes, then of course that can be resolved within that component. And why it's easy to do it over here, because later on if we have to do it like for the entire system, then it will be difficult to track it back to that which component is actually using the CPU more than the other. So it will take some time to track it back, while at component level, if we do this, then it will be easier and we can get it fixed right away. The next one is component integration testing. So over here, we can take an example of security testing. So now all these testings, which we will cover over here, are further types of non-functional testing. They fall under non-functional testing. So now security testing is another non-functional testing example. So we can check that to check for vulnerabilities when user interface info is passed to business logic. So in functional testing, we took an example where applicant age is passed from the interface to the business logic. Now, if we take the same example, but see it from non-functional perspective. So now what's happening, maybe when we are passing this information to the business logic, then maybe there is some security loophole. You might have seen that sometimes there are some security loopholes where when we enter any information in our form, and if we progress further, then sometimes in the URL on the top, we can see the data which we have entered, which is not a good approach, because that's a loophole that, like, sometimes that information can be retrieved externally by someone else, and that's how hackers basically hack the system without logging, etc. as well. So that's why this is when we integrate the components, how the information is passed from one component to another one falls under security testing. So this is one example. Then when we comes to system testing, so system testing, as we took the example of compatibility, that will fall under system testing. That compatibility testing to check if the same credit card application form works on different browsers and devices. So this type of testing we will do at system testing level. Next is system integration testing. So over here, we are doing reliability testing. So now over here, what we are doing, that we are doing reliable testing to evaluate robustness of the system if the external API fails to respond. So in the previous one, we took an example where we are integrating with another third-party API to check the credit score, which calculates the credit score and give us the response back. So over here, let's say that if that API fails to respond, then we are doing the reliability testing, that in that case, how well our system responds. How do we communicate it to user rather than showing them like service unavailable error message. So that will be reliability testing. Then coming to acceptance testing, usability testing can be one of the type can be used at acceptance testing level. So usability testing to check if the interface is designed for people with disabilities. So now, for example, there might be small fonts which on the website, on the form, which might be hard to read for people with some visual impairments. So that will fall under usability testing, and usability testing is a form of non-functional testing. So I hope that this type of testing is also clear. If there is any question, let's go through it now. Okay, nothing. So let's proceed. The third one is white box testing. Okay, so before we go through white box testing, in the further module where we'll be going through black box testing, we will also go through detail of white box testing as well at that time. In this lesson, it will be just an overview of white box testing. So don't worry if there will be few terms which you are not aware of or you don't understand. In this session, the aim should be that you have an overview of what white box testing is. And in further modules, then we will go through in detail different types of different forms of white box testing. Okay, so over here, the focus is that system's internal structure or implementation. It can be code, it can be architecture, it can be workflows, etc. So we are going through, we are taking an example of credit card application. Now a user can see a form, and after filling the form, we'll get a response. But between that, there are many things which are going at the back end. There's code which is being processed. There's a lot of architecture. There are different APIs which are being integrated. There are different workflows, etc. So all those fall under white box testing. Then it can be performed at all test levels. Okay, it can be performed at all test levels, but mostly it doesn't. So when we will go through black box and white box, then we'll see this, that if we talk about test levels, then usually white box testing is performed at component and integration level, while black box testing is performed widely at system and acceptance testing. But it doesn't mean that white box testing can't be performed at component level, at system level or acceptance level. We can still do that. Okay, so over here, there's a term we will use as structural coverage. So as in white box testing, we are going through the internal structure. So we use structural coverage to measure the thoroughness of white box testing. And the definition of structural coverage is coverage measured based on the internal structure of a component or system. So as we saw over here, the structure or the implementation can be in different forms. So whatever the structural coverage we are using, we can use that for measuring thoroughness of white box testing to see the percentage of the coverage. Then in white box testing as well, special knowledge might be required for test design and execution. And over here, we have taken an example of how to use coverage tools. So when we are doing white box testing, there are different kind of coverages which we do. Like we will do it in the further modules, but we do code coverage, we do statement coverage, decision coverage, and all these coverage can be done by different tools. So now we do have different tools which are mostly either built in IDEs, or there can be some external tools which can be used for all this. So for example, for Visual Studio, there is a built-in coverage tool which can be used for white box testing. Now we'll take the same example, but now we will see it from white box testing perspective. And because white box testing goes through the internal structure, so we'll take the same example and go through all the test levels, but we will see it from the structural perspective. So let's see component testing. So over here, the example is statement and decision coverage for all components that perform calculations. So in functional testing, we saw that we are saying that we are testing how the calculations of interest are performed, so how interest is calculated. Over here in white box testing, we are seeing statement and decision coverage. Let's not confuse ourselves with these terms, because we haven't covered that first. We will cover it in detail in further modules. But just to give an overview, statement coverage and decision coverage are kinds of white box testing approaches. So in statement coverage, we measure the coverage of executable statements within the code. And in decision coverage, we cover all the decision outcomes. So if we are using any if else statements, and depending on how many combinations are there and how many outcomes can we get, so we check that. So over here, we are testing that how the calculations can be performed, and in white box testing approach, based on how many combinations are there for statement and decision coverage, this testing can be performed at component level. The next one is component integration testing. How each screen passes info to the next screen and to the business logic, for example, age of applicant. Okay, so now over here, it's same example, but now let's see it from code point of view. So now we are not checking the interface. Over here, we are thinking of code that, okay, at front end, someone has entered their age, and then at that point, the code will have different workflows. If let's say that if age is less than 18, then it will be passed on to the business logic, and maybe the user is not able to proceed further. If it's 18 or more, then the applicant can continue with the application. So in this example, there are two statements over there, two decision paths, and based on that, the information is passed to the business logic, and based on the information passed, we get some response, and that's how the applicant is able to either proceed or just leave the application right there. So this is all covered in the code. Next, system testing covers sequence of screens that can occur during credit card application. Okay, so now over here, there might be multiple pages of the application form, maybe first personal information, then household information, and then employment, all those kind of things. So there will be in different orders, different sequence in which we see all those pages, and all that will be triggered in the code. So if we are checking the code as part of white box testing, then we are checking the sequences as well. So we are checking all the different parts. So that will be covered under system testing. The fourth one is system integration testing. All possible response types sent to credit score API. So now we are testing API itself under white box testing. So what we are testing, that an API always have a response, different requests, and based on the requests being sent, we get a response. So just like one scenario can have different test cases. So one API, one function of an API can have different requests and then different responses, and that will be checked under white box testing, and it will be done at system integration testing level. Then at acceptance testing, how white box testing can be performed. So over here, we can check if all credit card application process flows have been covered. Again, in white box testing, we can test all the parts, all the branches within the code. So acceptance testing, though as I said that white box testing is not widely used at that level, but we can use it in this way, that we can check that yes, all the application process flows have been covered and there is no gap in it. So this is all we need to know for white box testing in this session. And further, as I already said, that yes, we will cover it in much more detail. Any question over here? Okay, so first of all, there's one question. The name is not given. If client uses very old version of Android and software is working fine on all latest version, but problem in old version, then what we do in this condition? Okay, I'm just trying to understand the question again. Okay, so okay, let's say that there was an old version of an Android application, and let's say the version was 1.0, and you are saying that everything is working fine on the latest version. Latest version can be 2.0, but you are saying that but the problem in old version, then what we do in this condition? Okay, first of all, though there are two versions of Android application, 1.0 and 2.0, but they are not isolated. Whenever there is a new version, that's always built on the top of the earlier version. So if we have one build, 1.0, it went live, and then if we have a second build, 2.0, that will be built on top of 1.0. So that will not be like done from scratch. So if there is a bug which is in older version, then it will be there in the new version as well. But it might be that right now it's working fine because maybe that specific bug is the probability of occurring of that bug is not very high, and that's why there's a very edge case which can only trigger. But we can't say that that bug was in the older version and not the new version, or it might be that when the new version was being tested, at that point that bug was identified and maybe fixed, and that's why now in the new version you can't see that. So we have these two scenarios. So does this answer your question, or is there anything else? Okay, all right, that's good that it clarified. Okay, so Jatin is asking, who will do white box testing? Okay, Jatin, so over here, we will see that at which test level we are doing white box testing. And the rule will apply as we went through our test levels, that each test level we went through that who is doing the testing. So if it's component testing, we saw that it will be the developer, mostly the developer. So yes, a developer will be doing white box testing. And because at that point, a tester is not even involved, they are not doing any testing. Then in component integration testing, again, it will be the developer. So, or we also read that it can be a tester, but at that point, then that components and the code needs to be provided to a tester. Okay, when it comes to system testing, if we are doing white box testing at system testing level, then a tester should do it. But what happens that most of the times a tester is not that technical. If a tester is technical and can easily browse through the code, then then it's really good, and actually it's very, very helpful. So when we are usually a manual tester, even an automation tester as well, if a tester is going through system testing and checking the application, what they are doing, that they are checking, entering different inputs to the application form and then checking the response. So either they are doing black box testing, or yes, even if they are doing database testing, very few will have access to the code and will actually see the code as well. But I always recommend that it's always good to get access to the code. Always ask the developers to give you access to the code, even if it's like read only, it's fine, so that you are not messing up or you're not writing or changing or updating anything in their code. It's fine. Even read only will be very helpful. Like for example, when I'm testing, and if I come up with some uncertain behavior, I always go through the code as well, because sometimes code explains me that why the application is behaving in that weird way it is. So I can definitely raise the bug, but I will also understand that, okay, why over here in the code, something, maybe an exception was not caught properly. That's why we got this error. And while we are going through the code, sometimes we can identify many other bugs as well, which we haven't even tested yet. So we haven't even tested the UI first, but just going through the code, just going through the logic of the code, we can identify, oh, this is not good, and this will fail over here. But it's not necessary. Always testers don't test the code, but it's always a good practice to get access of that. So coming back to your question, who will do white box testing? It depends which level we are doing white box testing. So the same rules will apply, that who do the testing at each test level. And yes, the same people will do white box testing then. And why we don't do acceptance test, white box testing a lot in acceptance testing level? Because going back to the same level, who do acceptance testing? Either those are stakeholders, business users, product owners, and most of them, they are not technical people. They don't understand the code. So definitely it's of no use of doing it. But of course, if they know that, and if they want to go thoroughly uh, through the code at acceptance testing, they can definitely do that as well. So I hope that answers your question. Yeah, okay, that's good. Okay, so the last testing type we will cover today is change related testing. So whenever we are making a change in the system, that will come under change related testing. Now in change related tests, changes can be of two types. First is to fix a defect. So if there is a defect which we are fixing and then we are retesting, that falls under confirmation testing. But on the other hand, if there is a new or changing functionality, then we do regression testing. So there are two types of changes. One change is that either there is a new or changing functionality, and the other one is that there was a defect and the defect was fixed. And of course, when the defect was fixed, there would be some changes done. So the next one question is when it is done. Again, it can be performed at all test levels. Let's just go through these two types of changes in more detail. So confirmation testing, it confirms, as the name says, whether the original defect has been fixed. So let's take this example. So let's say we have a user story, and for that user story, we have 6 test cases. And what we will do when we will execute our test cases, we will go through each test case one by one. And let's say all these 5 test cases passed, but test case 4 failed, which means there is a defect in this section. So the test case 4 failed. So what we will do, we will raise a defect. When the defect will be raised, it will be forwarded to the concerned developer. So the developer will analyze, understand why the defect was there, and will fix the defect and give it back to us. And what we will do then, again, we will test this test case which was failed earlier. We will test that, execute it again, and to see that if now it's passing. If it's passing, which means that now this defect which we raised was fixed. So then eventually all the test cases will be green, will be passed. So this is known as confirmation testing, that whenever there is any bug raised, then you are retesting the same scenario to test the fix once the fix is done. So this is confirmation testing. Next is regression testing. So regression testing is to detect whether defects have been introduced or uncovered in unchanged areas of the software. So over here, let's take an example of this system. And let's say that there are 3 components in the system: component A, B, and C. Now, let's say that in this new version, we have made some change in component B. And we haven't done anything in component A and C. So we have just made some changes in component B. So whenever it will go to a tester, of course, firstly, component B will be tested under functional testing, because changes have been done, maybe new requirements have been added, or anything is changed over here. So yeah, of course, component B will be tested, but component A and C will also be tested under regression testing concept, because it might be that whatever we have changed over here might have affected component A and C, because there might be something which was being called in component A and C, or maybe in the overall flow, their changes were not intended to be done in A and C, but maybe something has changed. So whenever we release a new system, at the end, we also perform regression testing. So the regression testing is a strong candidate for automation, as these tests are executed very often, especially in Agile. So in Agile, if you're doing iterative model and we have a 2-week sprint, so what we are doing, we are taking new functionalities every 2 weeks, and at the end of each 2-week sprint, we are releasing that to live. But before releasing, apart from functional testing, we need to do regression testing as well, because maybe the new changes have broken something in the previous version, the previously, which was working fine, which we tested. And what will happen with each iteration, with each sprint, the number of regression tests, it keeps on increasing, and it comes to a point where humanly it's not possible to do it manually, because we have to do functional testing as well. And then at the end, regression test maybe starts with 10 test cases. It can go up to 500, 600, 1,000. So it's not manually possible. So that's why regression test cases, which are being tested very, very frequently at the end of each sprint, they are very good candidates to start automation. So whenever the automation is planned, it's very important to first of all identify the correct tests which should be automated, and regression testing are one of them. So I hope that this concept of confirmation testing and regression testing is clear as well. And this is our last slide for today. So for this type of testing as well, we will go through all test levels. So still the same credit card application example. At component testing level, we'll check automated regression tests for each component. So now the components, let's say when we started a system, there were only 5 components. And as we are progressing with the new version of that system, we are adding more and more components. And that's why it will be difficult to test all the components manually. So regression tests can be automated for each component, which means that if we are making only change in the one component, it's fine. We can maybe manually check that new function, but the old ones can be automated. So coming to this next one, component integration testing. Confirm fixes to interface related defects as the fixes are checked in code repository. So code repository is where, so whenever a developer is working, they're working on their own local machine, and then they check in their code, they commit their code to a code repository. It can be anything like GitHub or Bitbucket, or there are many other code repositories as well. So wherever, which means that over there, then when they are committing their code, then it's integrating with many other components as well, which maybe other developers are working. So over here, at this level, if due to change, if there is any issue arise, then that will be identified at this level. Then system testing. All tests are re-executed if there is a change in a specific screen. So in the application form, if there is any change on any field or any kind of change in that screen, then those tests will be re-executed, because now we need to make sure that after the changes, again, everything is working fine. System integration testing. Tests of application interacting with credit score API are re-executed on frequent basis. Okay, so now we have our own system where we have application form, and then there is another API, a third-party API, which we are using to calculate the credit score for us. So when we are integrating it, then there might be some changes, maybe some version changes, or maybe some other changes at our end, which for some reason doesn't sync with that API anymore. So we need to continuously keep on checking this as well, that the tests where the applications are interacting with the API, those tests are re-executed on frequent basis, and most of the time they are run on, they are scheduled to run maybe on every night, maybe every week, depends on how frequently the changes have been done, or how frequently you come up with some kind of issue, etc. Coming to the last one, acceptance testing. Tests are re-executed when a defect is fixed. So let's say that confirmation testing is that when a defect is fixed, then we go through the same test again, we run the same test again, and then if it's fixed, if it's working fine, only then that test case is signed off, and that will fall under acceptance testing. That let's say there were 2 bugs before, and at that time acceptance testing was failed, but then once the fix is done and the testers have done their testing, and then it comes again to acceptance testing level, and then whoever is doing acceptance testing, they are happy with the workflow, everything is working fine, then the acceptance testing will be passed as well. So that's all for the types of testing. Is there any question before we go to the practice questions? Okay, nothing. So let's go to the practice question. So which one of the following is true? So the statements are long, so take your time and then let me know that which option do you think is the correct one. Okay, so we have started getting some responses. Okay, Sahana is saying option D is the correct one. And then we have an anonymous attendee who's saying C. Mira is saying C. Madhuri is saying D. Okay, so it's Vineet. Okay, Vineet, now I know. Because over here, I can't see your name. It just says anonymous attendee. Right, okay. And Yuvi is saying C. Jatin is saying C. Okay, and C is the correct option. Let's go through the option again. C is saying the purpose of regression testing is to detect unintended side effects, while the purpose of confirmation testing is to check if the original defect is fixed, which is perfectly right. So confirmation testing, we are checking if the defect which was fixed is working fine or no. And in regression testing, we are detecting if there are any unintended side effects. So regression testing is done to just to make sure that any new change has not affected the other parts which were not changed. So C will be the right option. So few of you have also chosen D. So let's go through that and see that why you chose that. The purpose of regression testing is to check if the new functionality is working, while the purpose of confirmation testing is to check if the original defect has been fixed. So over here, the regression testing part is not correct. The purpose of regression testing is not to check if the new functionality is working. So let's not confuse regression testing with functional testing. So functional testing, whenever there is a new functionality, that will be covered at system level, and it will fall under functional testing or non-functional testing, whatever it is. But we are testing it as part of functional testing. Regression testing is which is done at the end. So regression testing is just like you can imagine it as like a stack which we are adding with each new version. So at the end we are just testing, doing regression testing to make sure that when one version on top of that is added, then nothing is changed in the previous one, because maybe there are let's say that first version and second version. First version was thoroughly tested because at that time, all the functionality was new. So we thoroughly tested that and no regression testing was required because it was the new function, new system. So we don't do regression testing if there is only like one new functionality. Let's say second time there was a new functionality, another one was added on top of the first one. So now, second functionality is the new functionality. So that will be tested under functional testing. And then at the end, we will do regression to make sure that this new functionality has not impacted the previous one. Over there, we will do regression testing. And that's why regression tests keeps on piling up. So I hope this one is clear. Okay, so Hannah is asking a question. What if new changes are implemented at the end due to some defects? Then we need to check the functionality during regression. Changes are, okay. So Sahana, when we are doing functional testing, you're saying that if there are any defects, so let's say at the end, if we are doing any functional testing and there are 5 defects, those defects need to be fixed before we start regression testing. So ideally, regression tests, just like UAT, shouldn't be done unless functional testing is done and signed off. Only then we start regression testing. So if there are any defects in the system, then those defects will be fixed as part of functional testing. So is that clear? Does that answer your question? Okay, Sahana is asking, what if new functionality is implemented at the end? Okay, when you say at the end, why a new functionality will be implemented at the end? Is it because there were some new requirements? Is that what you are trying to say? Okay, yeah, okay, yeah. It does happen, especially in Agile. So let's say that we are done, there were 5 user stories, and at the end, there's a new functionality being added. So what we will do that at the end, because it's a new functionality. So first of all, we will check that new functionality, and then yes, then we have to do the regression testing again. So let's say that there can be a scenario where we did functional testing of the sprint. Everything was signed off. Then we did regression testing, and we identified an issue during regression testing due to which some changes are required. So at that time, we will evaluate that how important that new change is. If it's not very important and it's not impacting our current release, then we can add it into the backlog, and then we can decide, oh, we can do it in the next sprint. But if it's impacting highly the current release, we just can't go without that, then we don't have any other option. Then we have to go through the entire cycle again. Then that functionality will be developed or changed, and it will be tested, and then again we have to do regression testing. So yeah, we have to do that. Okay, so I'm glad it's clear now. Okay, just going back, there's another question which I missed. So Manoj asked me, for every new software version, need to perform retesting whether defects are fixed or not. Okay, Manoj, whenever there is a new version, maybe they will, of course, if there's a new version, there will be new functionality as well. There might be some reason for new version. It can be either a new functionality, or maybe in the new version on production there was some issue found which maybe in testing was not found before. So these are the two scenarios. Based on that, we will get a new version, and then yes, first of all, in that new version we will either test the defect through confirmation testing, or we will check the or if it's a new functionality, otherwise, or we will do the regression testing at the end just to make sure that everything is working fine. Okay, Vineet is asking, what is gray box testing? Okay, so gray box testing is not actually a proper terminology in testing, but we do call it when we combine black box and white box testing, then we do call it as gray box testing. So what does that mean? That if we are combining the test activities of black box and white box. So black box is like we are just testing the inputs and outputs, and but in between, if we decide that, oh, we are maybe there's one part which is very crucial where maybe there are lots of coverage, different workflows based on different business rules. So maybe only that part we want to go through the code and like test it thoroughly as well, or maybe some other workflow, maybe the some part of the architecture we want to focus on. So what we are doing over here, we are combining the black box and white box testing techniques, which actually then is referred to as gray box testing. So we need the example which I just gave. Is that not clear, or do you want any other example for gray box testing? Which, so Vineet is asking which testing comes under gray box. Okay, so Vineet, this is gray box can be taken as a testing type and it can be done at any level. So it will, so there is not any specific testing. It's kind of testing technique. Gray box is a testing technique where we are merging black box and white box techniques, and it can be done at any level. And but on each level it depends that what we are focusing on, so based on that it will be different. So for example, if an example, I can give you an example of, let's say, again, we can take the credit card application. And if we are doing system testing, and system testing, we can combine black box and white box over there to make it gray box. So what we can do that we have some test cases where we have to test the entire application form, but then at one point where the credit score is evaluated, where the business rules are implemented, only that part we can go through the code as well, just to make sure that all the coverage, the code coverage is tested, and just to ensure that we have covered all the scenarios in our testing. So in this example, this will be gray box testing. Okay, so Vineet is saying, but somewhere I saw DB testing comes under gray as well. Yes, exactly. That will also, because, okay, what is black box? Black box is that where we are just testing like a user. So now a user doesn't have access to database. So anything which is where we are testing the workflow. And as I said, it's not any kind of structural testing is white box. It is not always code. It can be the architecture as well, the way the servers communicate to each other, or it can be DB as well. So you are absolutely correct. Yes, it will fall under gray testing as well. So one option when you are testing is that you just test like a user, fill in the application form, and at the end you see that yes, the application is successful, like you're able to go through the application process successfully. The other way is that as you are entering all the information and you're proceeding through the application process, you are also checking backend in the database as well, that everything is being stored in the correct table, etc. And you're also using some queries to test. So of course, that will be then more than black box testing. Okay, that's good, Vineet. I'm happy that now it's clear. Right, okay. So we have one more question which we have to go through. The second question is, which characteristics can be evaluated in non-functional testing? Okay, Vineet is saying D, Mira is saying D, Denmark is saying D, Sahana is saying D. Let's see if we have more, and then we can just go through the answer. Okay, so Jatin is saying C. Okay, so let's see if we have more. Madhuri is saying C as well. Okay, so Jatin and Madhuri, your answer is correct. It's C, it's not D. Let's see why. So let's go through all the options. Correctness. Correctness falls under functional testing. What are we doing in functional testing? That what the system does. Is it if we are testing the functionality, is the correct functionality being implemented? That falls under correctness, and which is not tested under non-functional testing. It's part of functional testing. Then let's come to the second one, which is completeness. That will fall under functional testing as well, because if we have a set of user requirements, then in functional testing we need to make sure that the system is working the way it was specified in the user requirement. So we are testing the completeness as part of functional testing. Yes, when it comes to security, it has to do nothing with functional testing. So testing activities like security, performance, usability, compatibility, portability, all those kind of testings, disaster recovery, failover testing, those are non-functional testing. So that's why C would be the correct answer. Is there any confusion on that? Okay, I'm happy that it's clear as well. Okay, so is there any other question for today's session? Okay, nothing. Right. Okay, then we can end today's session. And if there is any other question, you can definitely ask either me, just send me the message, or just ask in the messenger, sorry, in the group as well. And after this session, I will upload the PDF of the slides, and I will also upload the recording, and by tomorrow I will also upload the questions as well. And I will speak to you then next week. So till then, take good care of yourself, and be healthy and stay healthy. Bye.